Good morning, students. Today I am going to discuss the Faraday's law of electromagnetic induction. Faraday performed some experiments in the basis of which he gave laws of electromagnetic induction. The first law of Faraday says that whenever the magnetic flux linked with a closed circuit changes and induced EMF or the induced current is induced in it, which lasts so long as the change in magnetic flux takes place. This is also known as qualitative law. Qualitative law. The second law of Faraday states that the magnitude of induced EMF in the closed circuit or the coil is equal to rate of change of magnetic flux linked with closed circuit. So this tells us about the magnitude of induced EMF. So this law is also known as quantitative law. Quantitative law because it gives us the magnitude of induced EMF. We are going to find the expression for induced EMF. For this, let phi1 is the magnetic flux linked with a closed coil in the time at time instant t1, and phi2 be the magnetic flux linked with the coil at an instant t2. Then the change in magnetic flux, change in magnetic flux in time t2 minus t1 will be equal to phi2 minus phi1. Now from the Faraday's law we know that the magnitude of EMF is directly proportional to rate of change of magnetic flux. This means E is directly proportional to phi2 minus phi1 upon t2 minus t1, or E equals to minus k phi2 minus phi1 upon t2 minus t1. Here k is constant of proportionality, and in SI the value of k is equals to 1. So E can be written as E is equals to minus d phi upon dt. Here the negative sign indicates that the direction of induced EMF is such that it opposes the change in magnetic field. Now if the coil has n number of turns, then E is equals to minus n d phi upon dt, or minus d upon dt of n phi, where n phi is the flux linked with all n turns of the coil. Now the magnitude of induced EMF, if we talk about the magnitude, then magnitude of induced EMF is given by minus d phi upon dt mod of this, so it will be equal to d phi upon dt. If R is the resistance of the closed circuit, if capital R is the of resistance of closed circuit, then the induced current I is equals to E upon R, which is equals to d phi upon R dt. So this is the value of induced current in the coil.